this lesson, we'll be talking about the coordinate rules for reflections. By the end of the lesson, you should be able to find that line of reflection and reflect a figure on a coordinate plane without having to draw it. So our line of reflection means that we break our figure into two halves. So this reflection line could be the x-axis, it could be the y, or it could be some other line on the graph. For example, this red line in the picture, that's our line of reflection, because we can see from the red line to B is exactly the same distance as the red line to B prime, and from the red line to A and the red line to A prime. So our reflection rules means that we're going to make that change without having to draw it on a coordinate plane. So if we're going over the x, it means we multiply the y by -1, and if we're going over the y, we multiply x by -1. So in this box here are how the rules look. So we start with the xy, our ordered pair, and it changes to x negative y, whatever those numbers might be. Over the y, it starts as xy, and it changes to negative xy. So for example, if I have parallelogram ABCD, and it's reflected over the x-axis, find the coordinates of the vertices of the image. So after this reflection over the x, which means that we multiply y by -1. So point A, it was -4, 3. Now it goes to -4, -3. Point B was at 1, 3. Now it's at 1, -3. Point C is at 0, 1. Point C prime is at 0, -1. Point D is at -5, 1. Point D prime is -5, -1. So using the figure, identify the changes and write the rule. So we look at this figure, and point B is up here in quadrant 1, and B prime is down here in quadrant 4. So that means it's a reflection. And it went from 1 to 4, so you can see that's over the x-axis. So our rule goes from xy to x negative y. In the table, complete the original coordinates and coordinates after the reflection and write the rule. So here, A, B, C, that's our original reflection, our original figure, and the ordered pairs are 1, 3, 5, 2, and 4, -1. Then after the reflection, since it's going over the y-axis, that means I'm multiplying x by -1, so that after the translation would be -1, 3, -5, 2, and -4, 1. See how each of the x's is multiplied by -1? So the rule over a y-axis is xy goes to -xy. So let's look at some of these. If we look at this, we can see that it was 2, 8. Now it's -2, 8. That means I multiplied the x by -1, so it's a reflection across the y. In this one, it goes from 5, -1 to 5, 1. So the y changed, reflection over the x. It goes from 3, -6 to -3, -6. So it's the x that was multiplied by -1. So it's a reflection across the y. Goes from 3, -6 to 3, +6. That means the y was multiplied by -1, so it's a reflection over the x. This one's going from 5, -7 to -5, -7. It's the x that was multiplied by -1, so it's a reflection across the y. 2, 3 goes to 2, -3, so it's the y that's multiplied by -1, reflection over the x. It goes from 4, 9 to -4, 9. The x is being multiplied by -1. That means a reflection across the y. In this one, it goes from 4, 9 to 4, -9. That means the y is being multiplied by -1, which means it's a reflection across the x. If I want to do a reflection across the x, I take my ordered pairs, x, y, and remember I multiply the y by -1, so this 3, 7 goes 3, -7. 2, -1 goes to 2, +1. -9, 4 goes to -9, -4. And -5, -6 goes to -5, +6. Over the y, means that we multiply x by negative 1. So 3, 7 goes to negative 3, 7. 2, negative 1 changes to negative 2, negative 1. Negative 4, 9 changes to 9, 4, positive 9. And negative 5, negative 6 changes to 5, negative 6. So reflection over the x-axis means we multiply y by negative 1. And reflection over the y-axis means I multiply x by negative 1.